Hi, my name is Basir. In this video, I'll be teaching you properties of triangles from intermediate first year Andhra Pradesh and Telangana state syllabus. Even though properties of triangles is very easy, but then there are a lot of formulae that you need to learn. You have the sine rule, cosine rule, tangent rule, also known as Napier analogy, and then you have the projection rules, and then you have half angle formulae that can be a little bit overwhelming in the beginning, but then do not worry. I have your back. I will teach you everything that you need to know before we start solving questions from previous year question papers. So what are we waiting for? Let's get started. Hi, my name is Basir. So in this video, we'll start learning properties of triangles from intermediate first year mathematics. I have drawn a triangle A, B, C here. Obviously, A, B and C are the vertices of this triangle. And obviously this triangle has three angles, angle A, angle B, angle C. The side opposite to angle A, which is BC, we denote it by small a, and the side opposite to angle B, which is AC, we denote it by small b, and then the side opposite to the angle C, which is AB, we denote it by small c. And now let us say we have this circumcircle here. A circumcircle is a circle which circumscribes a triangle, which means a circumcircle is a circle which passes through all the three vertices of this triangle. Now such a circle is known as a circumcircle, and let us say I have this as the center of this circumcircle, and obviously this would be the radius of the circumcircle. The distance from the center of the circle to the circle itself to a point on the circle, you call it as the radius, right? So I have denoted this radius of the circumcircle by capital R. You can actually call it as circumradius also, because this is the radius, that's the radius of the circumcircle. You call it as a circumradius, which we denoted by capital R. And then I have inscribed a circle inside this triangle. You call it as the incircle, and the radius of the incircle we denoted by small r. The radius of the incircle we denote it by small r, and then I have extended the sides AB and AC of the triangle, and I have drawn a circle which lies to the exterior of the triangle ABC, which is outside the triangle ABC. We call such a circle as an X circle. The radius of the X circle we denote it by small r1, small r1. In the same way, I could have extended these two sides and I could have got a X circle here as well, and then we could have denoted the radius of that X circle by r2, and then in the same manner we could have extended these two sides, and we could have drawn an X circle here. We could have named the radius of this X circle as R3. So you don't have to worry here. These are the terms that you get to see a lot of times when you are dealing with properties of triangles. Capital A, capital B and capital C are the vertices of the triangle. Small a, small b and small c are the sides of the triangle. Capital R is your circumradius, which means it is the radius of the circumcircle. Small r is the radius of the incircle. R1, R2 and R3 are the radius of the X circle. You would also see something like delta. Here delta refers to the area of the triangle. Okay, delta refers to the area of the triangle, and then you would see one more letter, which is S. S is nothing but the semi-perimeter. Well, we'll talk about the area of the triangle and the semi-perimeter in a while. Now, properties of triangles, it has a lot of formulae here. So I see most of the students getting scared because of the number of formulae that you get to see in properties of triangles. But then do not worry, we'll learn all the formulae that are required for us to start solving the problems slowly and steadily. Okay, we'll learn everything one step at a time, so do not worry. Please be with me for the rest of the video, and I'm sure you'll be able to master properties of triangles in no time. Now, the first rule that we are going to talk about is known as Sine Rule. We also call it as law of sines. Now, law of sines is very easy. A by sine A is equal to B by sine B is equal to C by sine C is equal to 2R, where capital R is the circumradius, and we talked about it. Now, I'm not going to derive the sine rule for you because the derivation is not so important as per examination point of view. However, you would need to know the sine rule itself to make use of it in solving the questions. So A by sine A is equal to B by sine B is equal to C by sine C is equal to 2R, where small a, small b and small c are the sides of the triangle, and then capital A, capital B, capital C, those are the angles. Capital R is the circumradius. Now, from this sine rule, there are actually quite a few number of formulae that we can still derive from this. If I compare A by sine A with 2R, let us compare A by sine A with 2R, then obviously you would see for yourself that A can be written as 2R sine A. How? Sine A is dividing on the left hand side, so obviously it will multiply on the right hand side of the equation. So A is going to be 2R sine A. Likewise, you would also see that if you compare B sine B with 2R, small b is going to be 2R sine B, isn't it? Small b is going to be 2R sine B. And then small c, if I compare C by sine C with 2R, obviously you would get to see that small c is 2R sine C, 2R sine C. So these are three more formulae that we can derive from the sine rule. The sine rule itself is very easy. A by sine A is equal to B by sine B is equal to C by sine C is equal to 2R, and from this we derived A is 2R sine A, B is 2R sine B, and then C is 2R sine C. Now let us move on to the second rule that we are going to learn today. This rule is known as cosine rule, or you also call it as law of cosines. Now law of cosines, how is law of cosines going to help us? See, small a, small b and small c are the sides of the triangle. If you know the sides of the triangle, you can find the cosine of the angle. You can find cos of the angle if you know the sides a, b and c. So this rule is known as cosine rule or law of cosines. Since in a triangle we have three angles, angle A, angle B and angle C, you obviously would have three cosine rules. Okay, now this is with angle A, so there would be one more with angle B, and there is obviously one more with angle C. Since you have three angles in a triangle, you obviously end up getting three cosine rules here. Now remembering cosine rules is not difficult for us. This is something that I personally do to remember the cosine rules. I just draw a circle like this in a rough column, and then I write here A, B, C, and then let us move in this direction from A to B, B to C, and then from C to A. So that's what I have drawn here. I have angle A here. So after A, what do I get here? B and C. So I'll write B square plus C square, and then minus, I have A here, so I'm going to write minus A square by 2BC. If you understand the pattern here, I believe you will be able to help me with cos B. What would be cos B? After B, I get to see C and A. So I would write C square plus A square. Since I have B here, I'm going to subtract B square and then by 2CA. I hope you understood the pattern here. If you understood it, I'm sure you will be able to help me in writing the formula for cos C. What is cos C going to be here? After C, I see A and B. Okay, so I'm going to start with A and B, and then minus, since I have a C here, I'm going to write C square by 2AB. Now I hope you understood what we did here. Now from these cosine formulae, you will be able to derive the value of A square, B square and C square. So we'll be able to derive a few more formulae just by using the cosine rules. Let me find out what is A square from this one, from cos A. Now 2BC is dividing on the right hand side, so it is obviously going to multiply on the left hand side. So 2BC cos A, 2BC cos A, that is going to be equal to B square plus C square minus A square, isn't it? Now I would like to find the value of A square, so I want to make it positive. So A minus A square, if I transpose it to the left hand side, obviously it becomes positive A square, and then 2BC cos A, if I take it to the right hand side, it becomes minus 2BC cos A. So A square, I'm pushing it to the left hand side of the equation, and then 2bc cos A, I'm pushing it to the right hand side of the equation. So this is what I ended up getting. I ended up getting A square as B square plus C square minus 2bc cos A. In the same manner, I believe you can help me in writing what would be B square from this equation and what would be C square from this equation. I'm just going to use this pattern to find that. I'm not going to use this equation literally to get the value of B square, and I'm not going to use this equation literally to get the value of C square. I'm just going to use this pattern to understand what B square possibly can be. B square would be obviously, see, A square, when you wrote A square, you wrote the next two terms, B and C. BC followed by the cos of angle A. Now, B square is ideally going to be, after B, what do I see here? C and A. So C square plus A square minus 2CA, and then obviously I have B here, so I'm going to write angle B here. Okay, and then I believe C square is going to be, what is C square going to be? Let's see what it would be. C square is going to be, after C I have A and B, so let me write A square plus B square minus 2AB and cos of C. Now, if you don't understand these three things, you are, still in a good shape if you understand how to write at least the cosine rule. Cosine rule is pretty easy. Since I started with A, after A I have B and C, so I wrote B square plus C square minus A square by 2BC. I hope you would get to understand what cosine rules are and how they really help us. Cosine rules, they help us to find the cos of the angle when the sides of the triangle are given to us. And we obviously have three cosine rules since we have three angles in a triangle. Now let's move on to the projection rules. Let's move on to the projection rules. Projection rules are not difficult at all. You can try to understand a pattern here, and learning these projection rules are not going to be difficult. If you want me to prove this projection rule for you, I can perhaps prove it here. Let's do it this way. Cos C from our cosine rule, cos C is A square plus B square minus C square by 2AB, isn't it? A square plus B square minus 2A minus C square by 2AB. And then obviously cos B is going to be C square plus A square minus B square by 2CA. Now what really happens here? Now this B from the numerator and this B from the denominator, they cancel out, and again in the second term this C from the numerator and this C from the denominator, they cancel out. And what am I left with? I'm left with this thing here, A square plus B square minus C square by 2A in the first term, and then I'm left with C square plus A square minus B square by 2A in the second term. Okay, so now I see that I have two terms here on the right hand side. Both of them, they have the same denominator. So obviously the LCM is going to be the 2A here, and I can add up the numerators here. So A square plus B square minus C square plus C square plus A square minus B square. Now what do you get to see here? Let us cancel similar terms here. I can see plus B square and minus B square, we can cancel them out, and then minus C square plus C square, they cancel out. And what are we left with here? We are left with A square plus A square, which is nothing but 2A square by 2A. You know that this 2 in the numerator and this 2 in the denominator, you can cancel them, and then A square is A into A, so if 1A cancels from the numerator and 1A from the denominator, you will end up getting A on the right hand side. So you see that we have proved this projection rule, right? But then proving the projection rule is not the point here. I just wanted you to understand that we have used the cosine rules to get the projection rule here. Understanding the projection rule is pretty easy here. Personally, I would use the same concept. I would draw a circle here, and then I would write A, B, C in this manner. So I'm going from A to B, and then B to C, and then from C I go back to A. Now, if I want to write A is equal to, after A I have B and C, so I write B cos C plus, I will swap the places here. So C, I would write it here, and then B becomes the angle and I write it here. I hope you understood the point here. If you understand this, obviously since you have three sides in a triangle, you would end up getting three projection rules here. One for A, small a, and then obviously you would get one more for small b, and then you would get one more for small c. Let's see how many of you can help me in writing what small b is going to be like. Small b, after b what do we have? C and a. So I'm going to write C and then I'm going to write a, and then I'm going to swap their places. I'm going to swap their places. So A, I'm going to push it here, and then C, I'm going to push it to the side. I'm just interchanging those things. A, I'm not going to write capital A here because obviously capital A is the angle. It has to be associated with a trigonometric ratio. It cannot come all by itself here. So instead of writing capital A, I'm going to write small a, and then instead of writing small c here in the angle, I'm going to write capital C. So small b is going to be C cos A plus A cos C. If you understand the point, you would be able to tell me what small c is going to be. After C, I have A and B, so I'm going to write A here and then B, and then I'm going to swap their places. So this is going to be B, and then instead of B, I'm going to write here A. I cannot write a capital B here because it would be an angle. In that case, an angle has to be associated with a trigonometric ratio. It cannot lie there all by itself, so I'm going to write small b in place of capital B here. I hope you understand how I wrote the projection rules here. So we have three sides in a triangle, so obviously you end up getting three projection rules here. Let's now move on to the fourth thing that we are going to talk about. We are going to talk about half angle formulae. Obviously A by 2, we call it as a half angle. So we are going to talk about half angle formulae for sine, cos and tan, and then we are also going to talk about area of a triangle. This thing right here, I believe when you look at it, it should ring a bell to you because this is not new for intermediate first year mathematics. This is something that you already learned in grade 10 math itself. This is known as Huron's formula. That's your Huron's formula, and you use Huron's formula to find out the area of a triangle when the sides are given to you. When the sides A, B and C of a triangle are given to you, you use the Huron's formula to find out the area of a triangle, isn't it? And then if you may recall, you may be able to recollect that S here is the semi-perimeter. Perimeter is nothing but the sum of all the sides. I have the sides small a, small b and small c. The sum of small a and small b and small c is a plus b plus c, and semi means I have to divide it by 2. Semi-perimeter is nothing but the half perimeter. To get half of anything, you divide that thing by 2, isn't it? So S here is the semi-perimeter, which is a plus b plus c by 2. Now, sine A by 2 is going to be square root of S minus B, S minus C by BC. I'm not going to show you how to prove this because obviously proof is not something which is important as per examination point of view, but then you would anyways need to use the half angle formulae to solve questions in your examination. So you would obviously get, we have written sine A by 2 for now. But then you can write what is sine B by 2, and then you can also write what is sine C by 2. Do you think you can help me in writing what sine B by 2 should be? Since I have a A here, I wrote B and C here, and then I wrote BC here. So I'm going to use the same thing. Since I have a B here, after B I get to see C and A, so I'm going to write C here and then A here, and then I'm going to write CA. In the same manner, we can write sine C by 2 as well. Since I don't have space here, let me use this space here. Sine C by 2 is going to be, after C I have A and B, so let me write A here and then B here by AB. So these are the half angle formulae for sine. Let us write the half angle formula for A as well. Cos A by 2 is square root of S into S minus A by BC. So since I have a A here, I wrote a A and then the other two sides in the denominator. So I'm going to use the same strategy here, the same pattern here. Cos b by 2 is going to be under root of s into s minus b by ac. In the same manner, cos c by 2 is going to be under root of s into s minus c by ab. Now tan a by 2, you can get tan a by 2 when you divide sine a by 2 by cos a by 2, because obviously tan is sine by cos, isn't it? So when you divide these two, obviously bc and bc, they cancel out and you end up getting s minus b, s minus c in the numerator, and then s into s minus a in the denominator. I hope you can now find your way in towards getting what tan b by 2 and what tan c by 2 would look like. Area of a triangle formula. Now, when you have two sides given to you and an included angle, you can find out the area of a triangle by using this formula. How do you remember this? See, remembering this is quite easy. Delta, which is nothing but the area of a triangle, that is going to be half AB. Since I have AB here, the included angle here is C, so I wrote sine C here. Now, in the same manner, you can write it like this also, half. Let's say I write BC. The included angle between B and C is A, so I'm going to write sine A. And then the same manner, half CA, the included angle is B, so I'm going to write sine B. So CA, the included angle is B, so I'm going to write sine B. So delta is half AB sine C, half BC sine A, half CA sine B. So when you have two sides given to you and an included angle, you can find out the area of a triangle by using these formulae. Now, there are quite a few formulae that we can actually derive from this. There is some other thing that I can do here. Let me do it for you. Delta, which is nothing but the area of a triangle, that is half AB sine C, right? Sine C. Now, as per the cosine rule, I have C as 2r sine C, isn't it? I have C as 2r sine C. So sine C is going to be C by 2r, isn't it? 2r is multiplying on the right hand side, so obviously 2r is going to divide on the left hand side. Now in place of sine C, I can write C by 2r. So let's do that. In place of sine C, I'm going to write C by 2r. Now what happens? Delta is going to be AB into C, that gives me ABC. 2 into 2 is 4R as it is. So area of a triangle is ABC by 4R as well. Area of a triangle is ABC by 4R as well. Now, there is one other thing that I can try. I can use this to get one more formula for finding area of a triangle. I can perhaps try this. Delta is equal to half A. What is A going to be? C is 2R sine C, isn't it? So A is going to be 2R sine A. And then this B is going to be 2R sine B. And the sine C, I'm going to write it as it is. Now what happens? This 2 from the numerator and this 2 from the denominator, they cancel out, and then you are left with 2R sine A sine B sine C. 2r sine A sine B sine C. So this is one other thing that we got here. Area of a triangle is 2r square, because r into r, that gives us r square, isn't it? So area of a triangle is 2r square sine A sine B sine C. Now, we again have quite a few formulae to deal with, but I am going to talk about those formulae a little later in the video, or perhaps in the next video. For now, what we'll do is we will stop the video here, because I believe there has been quite a lot of download for you guys now. There are a lot of things that we talked about in this video. We talked about the sine rule, we talked about the cosine rule, we talked about the projection rules, we talked about half angle formulae and area of a triangle formulae. So let's stop it here, but then in the next video I'm going to use all these formulas to solve questions from previous year question papers. And probably in the video after that, I'm going to teach you a few more formulae, and then based on those formulae we will again solve questions from previous year question papers. Thank you so much for staying with me till the very end of the video. I look forward to see you all in the next video. Until then, goodbye.